Oh, great. Can you hear me?
Yes, sir.
Yes,
I hear
sir, we
you
can
now.
hear you.
Yeah, that's great. The thing did not go off. So I had to change over to my phone network. So they took my life. So the internet, the broadband went off. So yes. So very simple. You can see you arrange the subject 1 to 20, and you can just arrange the second column is the X, the value of each of them. Arrange like that. So for that second column now, you can add everything together. When you add everything together, that is sigma X. That is sigma means addition of X. Sigma X is 791. So to calculate the average is very simple. What do we do? The average, which is bar X, sigma X all over n. The n is 20. So 791 over 20, it give you 39.955. That is the mean for your group. Of course, the one you are comparing there, I'll be giving to you is 33. You know the other one, they didn't give you your own group. You have to calculate your own mean, 39.55. So, if you remember in the formula for the one sample t-test, you have the bar X minus mu over standard deviation over square root of sample size, which is the standard error. Standard deviation over standard. So that shows that for your own group now, you need to calculate that standard deviation. That's all. Because you already know the sample size is 20. So when you calculate the mean, the next thing is to. So the next two columns is for you to calculate the standard deviation. So the first column is the serial number, just arrange. The second column is where you put your heads, you're able to add all the together and calculate the sigma X, which is 791. You divide by the 20, which is the sample size, to give you the mean, 39.55. For you to calculate the standard deviation for this set, you have to, after you have calculated the mean, you now calculate the standard deviation. So the third column now is X minus X bar. That is X bar, which is the mean. You will remove it from the X. From each of them, you remove that 39.55. When you remove the, can you see the way they are? You remove them. Mind you, is another way. We can decide to arrange, this one now, I didn't arrange in ascending order the way the value of X is. If you arrange that, it doesn't change anything. The only pattern you will see that if you arrange in ascending order, although when you are removing S from each of them, those initial one will be negative until you change to positive later. But you see now, positive, negative, depends. So any value that is less than the mean, when you remove mean from it, because we give you negative value. Any value that is greater than the mean, when you remove mean from it, it gives you positive. So if you, this third column, which is X minus X bar, which is the deviation from the mean, that's the column called deviation. X minus X bar means deviation from the mean. That is the difference between each value and the mean. And mind you, as much that are positive will be negative because mean is in the middle, you know that, see the average. As much that are less than the mean will be greater than the mean. So when you try to remove mean, as much that will give you negative value, we also give you positive value when it comes to value. When you try to add it together, it is 0 you get. And that is why it is not useful to ask X bar or S bar, because the deviation from the mean we end up to be 0. That's why the intelligent people that have done this thing before, that's why the square. So the square, if you remember in chi-square, the same thing also they did. The only thing why they didn't call this one chi-square is or square is whatever is square, you go to reverse again. But in chi-square, there was no reverse. That's why they left the chi-square. If you remember, when you remove observer and expected, for all the different cells, some are negative, some are positive. If you didn't square it, they will negate each other. So it's the same thing here. So when the last column now is the square, when you square it now, it gives you square deviation from the mean. You know, x minus x bar is deviation from the mean. Squaring it means square deviation from the mean. So when you sum all the square deviation from the mean, that's what we call sum of square. When you sum it together, it gives you, look at the value now, sigma x minus x bar square. Can you see? Sigma x minus x minus x bar square is that column. When you sum it together, that's sigma. It gives you 2,908.95. Now, the variance now is the average deviation. Is the average sum of square. Average sum of square. You know, when you sum all the sum of square, average it, average square deviation, average square deviation. Because the square division, for you to calculate the average, you have to sum together and divide by the degree of freedom. Instead of n, you divide by the n minus 1. I've already established, I've already demonstrated the logic behind the degree of freedom in that context for you. Entity minus 1. So n minus 1. So when you now divide, the n minus 1 will be 20 minus 1, which is 19, because the sample size is 20. So 2908.95 divided by 19 now, it gives you 153. This one, 153 now, 0.10 whatever, is the variance. Variance, which is the average square deviation from the mean. Average square deviation from the mean. That is the variance. Of course, you know that the unit of the mean is the same unit as the variable. The variable x, when you calculate the mean, if x is for this one, and this is age now, this age. The mean also is, the unit is age. The mean age is 39.55 years. That's what it means. But this variance you have calculated will be 115 years square. No, you square it. It's not the same unit as the mean. So you cannot talk about average, which is 39.55 years. And now say the measure of this variability, which is variance, 153 years square. So it makes sense because you already squared, that's why it's carrying that. It makes sense for you to calculate the reverse of square, the square root. If you now find the square root of variance, that is the standard deviation. And that is why it is the standard deviation you quote with the mean. You see, mean plus or minus standard deviation, because those are the ones that have the same unit. And that's it. Mean, the square root of 153 is 12.37. So we cannot say, oh, the mean is 39.55 plus or minus 12.37 years. Because that one, they have the same unit. Because you have that square, you have reversed it by square root. So you will see standard deviation is the square root of variance. Variance is the square of standard deviation. It's like water and ice block. Variance and standard deviation is like water and ice block. If you need ice block, put water and freeze it. If you want to get your water back from the ice block, melt the ice block, it gives you the water. It's the same thing. When you square the standard deviation, it gives you variance. When you find the square root of variance, it gives you standard deviation. Now, so one sample T now will be bas x minus mu over s over square root of n. So we will put this one in 39.55 minus 33, which is the mu they give you, over 12.3746 over square root of 20. When you solve it, it gives you 2.367. So this is the T. Now, this is the one sample T. I think it's very, very simple. If this one come out in exam now, you'll be able to pass. True or false? Who cannot do it? Ask question. If this type of thing come out, who cannot do it? Ask question now. Don't be shy. So that that day. So if you ask question now, I will answer you. But it means I will ask question that day. You have to answer me. So
Sir. I just have a question.
Okay.
So after you calculate the frequency, which is x, then
No
how
frequency.
do you
Wait. There's no frequency here. Listen. Which one is frequency? There's no frequency here.
now
You talk about frequency here.
no after you added all of x to this thing, you add all of it and it gives you 791. Then how did you get by
sigma x? That's sigma summation of all the x. Yes.
How did you get the by x then?
By x. Look at the formula, the first formula up there on the right side of the table. By x is equal to sigma x over n.
Oh.
So
okay.
N is 20. Just 791 over 20. Simple. It give you by x mean.
Okay, then how did you I want to know, in the sample, in the calculation for one sample T, how did you how do you get the target value?
It will be given to you now. That target mean, right? If you remember in the question, look at the question. The Nazi, after they have listed the ages, the Nazi, look at the third line, the end of the third line. If the mean of victim in a neighboring country was 3 years, that's the target one. Can we say that the mean age of affected victim is the same in the two countries? They tell you that these are the age of the people in your own country. They will not tell you the mean, but of course you can add it together and calculate the mean. But they now give you the mean of another group. So that is the target mean. That's the population mean. Does it make sense now?
Yes.
Yeah. Any other question?
Yes.
So any other question? Okay. There's no question. So if there's no question, we proceed. Yeah. So if we are to run in with SPSS, let me bother. If we give you something like this, look at the output. The first table up, you see age. It gives you the sample size in 20. The mean is 39.55. The standard deviation is 12.374. Those are things you calculated with hand. Standard error, you also give you standard error, which standard error is the standard deviation over square root of sample size. If you calculate it out with your hand, but it's only that we didn't calculate it separately. No, we did it together with when we're calculating the. So all those things, the computer run it for you. Then if you now come, look at the T, 2.367. Then the degree of freedom is 19, as you have seen, so 20 minus 1. And the only thing you cannot calculate with hand is the p-value. But the computer gives you the p-value, 0.029. And the only other thing I want to bring out here, which normally may not need to do, is we don't actually even ask you when we are, because this table you are seeing, the second table now, is presenting two inferential method. It presenting, but when we talk about introduction to inferential statistics, I talk about two inferential methods: hypothesis testing and confidence interval. So this table now, computer garbage in, garbage, they are programming It does both. It gives you both hypothesis test and confidence interval. So up to T degree of freedom to P value, that is hypothesis test. This mean difference, 95% confidence interval, up, lower, and upper, that is confidence interval. Can you see now? There are two different things, but they are both inferential method. So now, if you are running with the SPSS now, it will just give you this. And how will you know, for example, now, without the P value, the T, you can know if the difference between the P is significant. You see, the confidence interval must not include 0. We know that if the two mean are the same, that shows that the mean difference will be 0. The difference between the two mean will be 0. If the difference between the two mean is 0, it means that there's no difference in the two mean. So when you calculate the mean difference, if you look at it, if you calculate with your hands, the one they gave you 33 here, your own is 39.55. Remove 33 from 39.55, it gives you 6.55. That's what the mean difference this computer gives you. 6.55. That's the mean difference. So the 95% confidence interval of the mean difference is 0.76 to 12.34. Can you see? So what it's telling you is that the difference in my sample you just did now is 6.55. But in the population, you are 95% confident that the value will be anything in between 0.76 and 12.34. Does it make sense now? So don't let that one confuse you, because if I give you this question to solve now, we are not going to solve this confidence interval there. It's only you calculate your T and you look at the statistical table to see. And if you go back to the statistical table, I show you the T distribution T table. Under 95% confidence, 2T. Look at 2T, 95 and 0.05. That is if you look at the number 3 column to the last, third to the last column. That's what you are looking at. You look at degree of freedom of 19. If you look at the degree of, what is the critical value? What is the value for the degree of freedom of 19? So it will be something around this 2.086. The critical value will be around 2.086. But what you have calculated is 2.23 something. It means that the value you have calculated is far above the critical value, because that critical value will correspond with the 0.05 degree of freedom. Sorry, P value. But since your own calculated value is higher than that critical value, that's so that your corresponding P value will be less than 0.05. So when you calculate your hand, you cannot actually calculate the P value. You can only know if your P value is going to be less than or it's going to be greater than. So when your value is greater than the critical value, that's that your corresponding P value will be less than 0.05. But if we run it with SPSS, it will give you, you run it with software, to give you the P value. So I don't know if you understand the interpretation now, so that we'll proceed. Any question? So let's look at independent sample test. So independent sample t-test. This is otherwise known as independent measure t-test or independent sample t-test or simply student t-test. So this is what Mr. Gosset actually described initially. That's why they call it student t-test, because he was published under pseudonym student because where he was working in Guinness in Dublin, was a staff there. There was no way could publish their data without permission. They will not even, they are business people. They will not want you to publish their data. Business people, they only want people to know about what they want you to know. They don't want people to know the secret of their business. So you cannot be in a business and begin to publish their data. So you leave the job, you lose your job. So he was publishing, was not putting his name. He just say student. So that was how they call it student t-test. But it was later we now got to know that it was Gosset that was behind the scene. So it is used when there are two experimental conditions and different participants were assigned. Those are options. It's not only one. Possible situation when you use it are what you use. Or there is one experimental group and one group, or comparing two groups in an observational study. Just know that you are comparing two means. That's all. It doesn't know whether it comes from anywhere, whether it comes from experimental design or a comparative study, because the study design, the statistics does not know study design. It's you that know studies design. Statistics does not know. What statistics knows is, are they two groups? The two groups, are they independent group or are they peer group? Those are the things. So, but those are the different scenarios that can fit into it. So leave that one. Let's talk more about epidemiological. Let's talk also on the statistic aspect. So you're familiar with the formula. Now, an example now. The table below shows the number of days lost to absenteeism per month over 15 months due to sickness in a mining and a construction industry. Can we say that the mean number of days lost differ in the two industries? So here now, over a period of 15 months. So you can see the sample size here, logically is 15. So for each mining construction, the number of days lost to absenteeism by a worker is. Can we say that the number of days lost differ, or is it the same? So you know that for each of them now you can calculate the average. That's what you can calculate the mean. So there are two groups. It's not like one sample t-test where they give data for one, they now give you the mean for the other one. No, this one now, both of them you have the data for the two groups. That's why it's two independent sample t-test. And the sample are got it from two different groups of people. Now, computation. So if you look at it in the formula now, two things, what are the things we need to know? We want to know the mean of the two groups. We want to know the standard deviation. And the sample size you already know, they are 15. But you just want to know the mean and the standard deviation. Just like the other one, even the one sample test is for you to know the mean and the standard deviation, you feed in. So you can see that all these t-tests is just a step, a little step further. After you calculate mean, the standard deviation, which is normal thing to do. So let's look at the mining. For the mining, if you list them by X1, that is group 1 mining, you list the value. Sigma X means you add all the value together. Everything for group, the first group is, the mining is 87. And if you divide that 87 by 15, the mean will be 5.8. That is, see, sigma x over n over 15 give you 5.8. The same thing for the construction industry. You list everything, you add everything together is 56. And you divide by 15, it gives you 3.37. So now, the one that is more difficult is to calculate that standard deviation. Because calculating the mean is very simple. So to calculate standard deviation, the additional two columns, x minus x bar. Of course, before you can calculate standard deviation, you have to calculate the mean. You have to remove mean from each of them. When you remove mean from each of them, as usual, you now square it. That is, mean x minus x bar is the deviation. When you now square it, it's square deviation. So when you now sum the square deviation, which is sigma x minus x bar square. So when you now divide it by the standard, by degree of freedom, n minus 1, the sample size is 15 for each of them, which is n minus 1 will be 14. So 50 for this one now. When you sum everything together, sigma x minus x bar square, it gives you 58.1. For the construction, it gives you 16.9335. So when you calculate you divide each of them by their standard, by the degree of freedom, 14. It gives you, the mine give you 4.17, the other one give you 4.35. So square root of each of them, of this variance, it gives you the standard deviation, which is 2.042 and 2.085. Can you see? So these are the things you feed into the formula on this side now. You feed it, you get 2.742. So it's very simple. It's just for you to know the logic. Adija that is disturbing the class. So the same thing. Any question on this? There's no much difference between, it's the same step. Any question? Ask question like the way Amina, is it Amina that asked that question that time? Ask question. Because some people are cooking now. So ask your question so that I will answer. So the day I will ask my own question, you must answer. So if we run it with SPSS also, it gives you, look at two typical tables that will come out. They show you the sample size, the mean we have calculated, it will give it to you. The standard deviation, standard error will give you. It gives you 11 tests. This nitty-gritty now, we talk about homogeneity of variance. That one of the conditions for using parametric tests is homogeneity of variance. 11 tests, first tests, these two groups, are their variance the same? That's the F you see here. So this one now, the p-value for that F is 0.185. The p-value is 0.670. Mean that there's no difference. But it's not significant. It means that there's no difference in their variance. So there's homogeneity of variance, which is okay. So you now go away and go further. The T, look at the T. Even the SPSS will give you, if there's no homogeneity of variance, it gives you two options. If there's homogeneity of variance, that is equal variance assumed, or there's no homogeneity of variance, equal variance not assumed. It gives you two possible values. But sometimes you see the value are almost the same, like in this case now. So the degree of freedom is 28. You know that there are two groups. Each of them is 15, 15. So each of them, 15 minus 1, 14. 15 minus 1, 14. When you add the two together, I give you 28. Or you say n plus n minus 2. 15 plus 15, 30 minus 2 give you 28. The degree of freedom is 28. So you remove one from each sample. So the p-value is 0.011, which is significant. Even the t value, which is 2.742, remember, if you go and check the degree of freedom of 28, this value will be greater than the critical value. The critical value is not up to this value. It's not up to 2.742. That is why you will know that the corresponding, even though you cannot calculate the p-value with your hand, you will know that the corresponding p-value will be less than 0.05. So the computer will give it out. The same thing also will give you the confidence interval. So don't let us talk about that confidence interval here, so that people will not be confused. Because if I ask you to solve this test, we are not asking for confidence interval here. If you want to ask, it's another ball game. So this one, I'm just showing you the expresses, and that is actually over the year discovered that you students, you are not serious to learn anything. You just want to pass. Because normally, what I see, I tried organizing the expresses so that you know how to use machine to run this thing. That's the beauty of it. You have the skill. So when you finish your MP, you know that you are skillful. The people are carried away by, they don't have the time to learn. So, any question on independent sample T? So that we discuss the last one, which is pair sample T. Pair sample T. I'm not hearing anything. People are sleeping. Are you there? Amina Abdul. It's you that usually ask questions.
Yeah, yes.
Yes, sir, we are here.
Okay. Adiola, Cynthia, okay. Yasmin. So let's look at paired sample t-test. This is also known as matched pair t-test or dependent t-test. You see the reason. So what are the scenarios in which you use it? Where there are two experimental conditions and the same participant took part in both. When your measurement, you measure the same people you measure on two occasions. That's what you mean. Comparing means of measure taken before and after an intervention or experiment, or comparing means of repeated measure taken from same group in observational study. It doesn't have to be experimental design. Even in observational study, comparing means of peer observation measurement from the right and left side, eye, ear, anything that occur in pair in the body, breast, teeth, nostril, eye, hair. If you measure the intraocular pressure of the two eyes, you can compare. Because it's the same person that has the two eyes, so you can use pair t-test. You take measurement from two, maybe sides of right or left, upper and mid, upper. It has to be upper and upper, mid, lower and lower. Maybe size of breast or whatever, or hand, even the finger. Anything that occurs in pair in the body, and use it. So it's very simple. It's very simple, like one sample t-test, in the sense that look at the formula. This formula is the simplest. It's the one that actually depicts what we are talking about. Look at it. T is equal to bar D. Bar D means the mean of the difference. We're going to look at it over standard error. You know, the standard error is standard deviation over square root of sample size. So the mean, the difference you are looking at over the inherent variability, which is standard error. So it's so simple. Now, example. Because when you go through the example, you understand it better. The table below shows anxiety score before and after counseling of 9 persons prior to disclosing to them their HIV status. Did the counseling significantly influence their anxiety score? So these people, before you have done their HIV, you want to tell them the results. So you measure their anxiety Then you now do counseling. You mention that you want to see, just want to see if counseling has a way of calming people down. So you measure their anxiety score before counseling and after counseling to see the effect. So you can see the score from looking roughly. You see that generally it's like the score after is far lower than, it's averagely lower than score. Not necessarily that for all of them. There are some that the score was higher and lower. Generally, it appears that the score become lower after the counseling, showing that the counseling helped to improve their anxiety. So if you want to confirm that, you calculate the average of the anxiety. Look at it. Look at the table. So the first column talk about the subject, the numbering, 1 to 9, serial number. The second column is score before counseling. The third one, score after counseling. SBC, score before counseling. SAC, score after counseling. So you can actually calculate their mean. If you look at before counseling, sigma X, then if you divide by 9, it gives you 116.33. For after, you can see average is 83. Averagely, you can see that it's lower. Averagely is lower, it's smaller after counseling. But what you observe is that's observe different you see. You have to put it to test. In order to, now, you will see in the one we did before, independent sample T, you see X1 minus X2. What you are looking at the difference between the two means. You have calculated the two means, you look at the difference between the two means. That will say X1 minus X2. But here, even though you may calculate the two means before and after, it's not just by removing it. The way they do this is not just by removing 83 from this. No. This one is mean of the difference. The other one is difference between mean. You will have calculated the mean for the other one. You now say S by X1 minus by S2. But here, you will not do that. You now have D. This fourth column, which is D, is the difference for each person because number one, you did before and after for that person. So the two measurements, they are related in the sense that they are from the same people. It's unlike the other one that are from different groups of people. This one from the same people. So for each person now, you look for the different first. See, like minus 191 minus 76, it gives you 45. 93 minus 93, it gives you 0. 105 minus 64, it gives you 41. 115 minus 117, it gives you minus 2. 130 minus 82, gives you 48. 98 minus 80, gives you 18. 142 minus 97, will give you 63. 118 minus 67 will give you 51, and 125 minus 89 give you 36. Can you see? This is the difference. You now this difference now. You now add it together. Sigma D give you 300. You now divide this sigma D by 9. It gives you 33.3. So 33.3 is the D, is the mean of the difference. That's all you are testing. But independent T, you are testing the difference between two mean by X1 minus by S2. The here is by D. So by D is 33.3. So in the formula, you remember the formula, if you come back, pair T is by D over standard deviation of D over square root of N. So that same thing, standard deviation of D, you have calculated the mean of D, which is by D. What of the standard deviation of D? You need it. That's why That's second to the last column. D minus bar D. You begin to remove bar D from each D to give you, when you now square it, which is D minus bar D squared. Now, the sigma summation of it is 4,204. So you now calculate that calculate the variance. The variance will be, look at it now. Look at up here. Oh, n minus 1. Variance of the difference will be sigma D minus D squared over n minus 1. N minus 1 is 8 now because the sample size is 9. 9 minus 1. So it now give you variance to be 525.5. Of course, standard deviation, square root of variance will give you 22.92. So you now come now, you feed it into the formula. Bar D, which is 33.333 over standard deviation of D, which is 22.923, divided by, sorry, the slash is supposed to be there, divided by the square root of sample size 9. So when you do it, it gives you 4.362. So the degree of freedom is 8, n minus 1. So if this value is far, very high, that's why if you run it now, the value is going to be very, very significant because the P in the critical value for that degree of freedom is very small. So this one now, 4.3 is will be far above the critical value. So if you run it, look at what I said. You can see running. So the P, where is it? Okay, the way this one arranges, you put the confidence interval first before. Can you see? The P value is 0.002002, very small. So it's the same interpretation anyway with the previous one. So any question? Any question? So any of this one can come out. So all this other one, I don't even need to build up myself by non-parametric because we have talked about it. The non-parametric counterpart. These are for them. So it's not for you because if I begin to teach you this one and bring it out in exam, your head will scatter. So it's something you should know in addition, but the basic the common one, you should remember to know how to do it. So any question? No question. Okay.
I have a question.
Okay, go on.
So when you are giving us the values and everything, like the sample sizes, are you going to tell us which of the t-tests to use, whether it's paired t-test?
How can I tell you? That is part of the test now. I will not tell you. If you look at the question, those 3 questions we answer now, nobody tell you anything there. You see, they will ask you, can this, look at this last one now. It's you that will use your brain now. You say, look at example. The table below shows anxiety score before and after counseling of 9% prior to disclosing to them the HIV status. Did the counseling significantly influence their anxiety score? From when you say that before and after, and you see the table before and after, now, oh, this is pair T. And you see that it's from the question you know. So nobody will say use pair T. Who will tell you that? So they have already given the way the answer now. So look at the other one. They say, can we say that the mean number of day loss differ in the 2 industries? You can see that this one, there are 2 separate independent, you know that independent t-tests. From the arrangement, from the problem, you know. When you read it, you know this is independent sample T. So is it the first one also? Everything is straightforward. They say, can we, if the mean age of victim in a neighboring country was 33 years, can we say that the mean age of affectability is the same in the two countries? So here now, nobody told you anything. It's you that will know, oh, this is one sample t-test. Any other question? No question, right? It will be okay. If there's no questions, okay. Good night, everyone.
Good night.